This is section 2.4, Limits and Continuity. And in this video, we're going to go through an example of how to solve for when they're asking us where a function is discontinuous. Alright, so this is number 23 in your book. It gives us this function, and it's asking us to find the points of discontinuity. Okay, this function makes it kind of nice because it's a fraction. Whenever you see a fraction and you're solving for discontinuities, all you want to do is just set the denominator equal to 0. You're looking for values of x where the function is not defined at that point. In other words, where it's discontinuous. So remember, you can't divide by 0, so let's set the denominator equal to 0, find our points of discontinuity. When we set 4x minus 2 equal to 0 and solve for x, we get 2 over 4, or 1/2, and that's it. Our point of discontinuity is that x equals 1/2. And just a pro tip, whenever you have some number over 0, that's going to give you an infinite discontinuity. There will be an asymptote at that point, x equals 1/2, and the graph will be going either up to positive infinity or down to negative infinity. And if you want to think of why this makes sense, why it's an infinite discontinuity, let's think about it. As x is getting closer and closer to 1/2 from both the right and the left side, this value is getting closer and closer to 0. It's going to become a really, really small decimal, either positive or negative. As a really, really small decimal gets divided into some other number that's bigger than it, that really, really small number, for it to go into any other number, it's going to need to go into it an infinite number of times. So that's why when you set the denominator equal to 0 and solve for x, at that value, you're going to have an infinite discontinuity.